the other day buying some washers or whatever, and there's a tin of silver hammerite lurking on the shop shelf. So what am I going to do? The only pieces I've had to prime has been the motor and the gearbox. That was already painted blue. I wasn't sure how the paint was going to cover that. It seems to be fairly thick stuff. Contemplated all sorts of colour schemes and everything else, but there is actually so little surface on this machine that's going to be painted, which will be the raw cast surfaces and the roughly filed surfaces. It doesn't really make for much of a colourful machine. It's still going to look mostly silver, so silver hammerite it is. All of the other parts, they've all been masked and hung up on a kind of washing line affair. Hopefully they'll only need one coat, but if they need more than one coat it'll become very tedious. And this stuff takes about 4 hours to dry anyway, so I might be able to get 2 coats done in one day. I've actually peeled the masking tape off of all the other parts, and I'll do these jaws now even though the paint's still wet. I've got to say I'm pretty underwhelmed by the colour scheme. The whole thing just looks grey and shiny, but I don't think I'd have been happy with it whichever way it turned out. Trouble with painting things colours, you just have to live with it forever. So the alternative was to just leave it unpainted, but I'm glad I didn't, because it would have turned into a oily, scummy mess. Whereas with this I've got half a chance of keeping it clean. Last thing from the motor end of it, the capacitor. I have made the capacitor matte black all over. It sits in the dark shadows of the rocker assembly, so it's just going to sit there being dark. I've left a little bit of masking tape on that over the specifications of the capacitor, so that in 150 years time, when it finally breaks down, somebody will be able to buy another capacitor for it. That's the plan. What I'm going to do now is put it all back together and try and provide some kind of wrap-up commentary on how this all went. So the first thing would be to put the vise together. There's the vise all in one bit. This was the first assembly I made purposefully, because it is a standalone assembly. You can make it and then you have a finished thing. Also it doesn't add anything to the functionality of the machine, if you like, so making the vise first, you make no progress in being tempted to just half finish the machine. Probably the worst thing about this is this alignment of this boss and these threaded holes. they simply don't line up. The measurement on the drawing is wrong, so I just blindly followed the measurements and drilled the holes, and this is how it turned out. Doesn't make any difference really. Because I was new to the milling machine, it was a new milling machine when I started this, I wasn't used to the machine and ended up making a big super gouge in the slot there. Overall it was quite a hard part to keep hold of. This is probably the hardest part to make because of all the dimensions that you have to hit and all the measurements that you have to make. Not easy, so put that to one side. It says in the literature that this is cast very flat, so it needs minimal face cutting to get it flat. Well, it took a bit more than minimal. It's quite frightening. Some of this has ended up like 3mm thick. Not very thick at all, but it didn't go through, it didn't break through. There's a few porosities in there. I did have to choose which side I was going to put this switch. I decided to put it there with the ugly side next to the switch. Not sure that was a good choice, but there it is anyway. And it was a matter of, as the parts were made, placing them on the base plate, making scribe lines, drilling the holes as per the measurements that I had scribbled and made note of all the way through. And drilling the holes accordingly. One thing throughout all of this is that very few of these parts have got through holes drilled with them. The drawings will ask for holes to be drilled all the way through this part, and then a screw and a nut used to secure it down. Well, that leaves a lot of exposed hardware. It's just plain ugly. The other comment about these stanchions or trunnions or whatever they're called, there is a call out for an R12 or a ½ inch radius to be cut on one of these corners here. It serves absolutely no purpose whatsoever, so that didn't get done. This cross bolt as well, this is called out to have this diameter, have a waist put on it to reduce the diameter here so that you have two larger shoulders. Again, serves no purpose whatsoever, so that didn't get done either. There's the shaft. I did turn the shaft down to the finished diameter and left it like that throughout most of the build, because once you put that key in, you can't easily rotate everything and get things to fit, because the key is in there, so you can't turn that shaft anymore. It becomes a bit of a bind. So throughout all of the build, that key was not present until right at the end. It was only at the end that was probably the last machining feature I did. This is all machined so that there are no shims or adjustments needed to make to get these bushings lined up with the gearbox there. What that does mean is it does make it a little bit more difficult to put together. Not overly difficult, but things have to go together all at the same time. The overall machining of this was pretty tricky to get this all lined up. Comment on these spacers here, they give you a piece of 1 inch steel, 1 inch square steel to make these spacers out of. There's no need for them to be steel, aluminium would do just as well and be easier to deal with. That motor did all come to pieces, and the excess end of the shaft was turned off in the lathe, so that's nice and tidy. All good. Next up is these, whatever you call them. Next on was this piece of linkage and the cylinder, which is hanging up because it's full of oil. This casting here ended up being completely machined all over all of its surfaces. It's a casting that's got a lot of excess material on it, so it all got taken off. I also drilled some incorrect holes in the base plate here, not paying attention, but it's the same deal again, blind holes, studs in the bottom, nothing showing through from the top. Here's the dash pot or the damper. One mistake on this, I machined this piece 1mm off centre, so it's compensated for it in the slot of the foot that it sits in, which does mean I have to get it the right way round, and I'm not sure I've got it the right way round. Now we come to putting the electrics all back together. There we are, so nobody can electrocute themselves by molesting their fingers underneath it. So tighten up this gland, reconnect these wires up the top here, and that's the electrics back together. Before I finish on the electrics, pointed it out before, but I'll do it again. This power line on the instructions and the build note says put it on the side here, or to suit your workshop wherever your power socket happens to be, but putting a plastic grommet on the side of this base frame is asking for the plastic grommet to be broken off almost immediately. So I've stuck it in the top there, in between these two other pieces of structure to protect it a little bit, so it's unlikely to get knocked off where it is. Now that I've got the slide bar on and everything's tightened up on this rocker, the shaft has become lovely and free, as it should be. No worries there about reassembling it. This is an extra edition, there's no mention of it anywhere on the instructions. There's a thrust washer, brass one, that's going to go there up against the wheel, and there'll be another thrust washer at the other end of the shaft, which I'll get to in a moment. The reason for thrust washers is that the only other method of infloat on this machine is the key. the key in the shaft, which would have been expected to bang up against each end of these bearings in here. Using a key to control the end float of something is clumsy. And this collet, although I've made this collet and it all went fine and everything else, not a fan of it. It doesn't provide much grip. You have to do it up so tight to get any grip. But that's a restriction of the material available. It's a very thin 11mm shaft, and you try and secure a wheel to it that's that big. These shafts really should have like couplings on them, and you know, they drive small shafts. It's not a very powerful motor. That puts some pinch on these thrust bearings, which got rough surfaces on them, so they'll wear in, but it gives good end float control on that shaft. Now, to oil all of these bearings, it's a matter of pushing an oil bottle into that plug oiler at this end. That'll oil all of this bearing. Same at the other end. Push a plug oiler into there and all of that bearing will be oiled. In my enthusiasm, I have put the base on the machine, which I've got to take off. This wooden board, I've got to take that off again to be able to put the vise on. Similar thing with the vise, blind holes in the bolster, as they call it, and studs. This did get a left-hand thread on the lead screw, so it does tighten up the natural way. The notes also call for the nut on the end of the vice screw to be tightened up to get the end float right and then glued in place. That was never going to do, so this got a couple of lock nuts on there. This is all metric, these are M10, that's M12 left-hand thread, and a little brass thrust washer in there because it's this end that takes the load of the vise. Trying to build some durability into it. So that's all the vise features. The vise in its place. It does have a work stop should I ever need it, but it's stored up on the side of the machine. There's still enough room for this switching off mechanism to happen. And if I'm not mistaken, I can put the base back on. Here we're going to have all the frame go back together. I did position this pin actually too far towards this end. Could have been doing about another 3mm further back, because the pin now clashes with the blade clamp. I'll put the blade back in it while I'm here. They give you a 24 teeth per inch blade. I wouldn't recommend that. It's too fine. It'd be too fine for aluminium and whatnot. So I've got some of these Kennedy brand 18 TPI 10-inch blades. Now early on, during the first test cuts I made with this thing, there was a lot of clattering and banging every time it went through top, bottom and top dead centre. There'd be a knock, and what that was the rocking up and down of the blade frame, the bow. But one thing I will give it, these bearing caps are a pretty good design in that you can close up the vertical travel as you tighten the caps on. So that will give the absolute minimum amount of slop in the vertical direction. You see it's actually quite tight on there. And I'm going to leave it like that because I want to get a bit of oil in there, a bit more running. That's what I'll be looking for. Okay. Might as well put the connecting rod on. That'll be the next step. Along with the main shaft, this connecting rod had no real end float control built into it either. So thrust washers for this big end got made. So the thrust or the end float was adjusted by putting a little counter bore in the end of this nut here. So this nut only goes on one way, which is that way. That provides about 0.1 end float. There's no need to control this end because it's controlled at this end. That will allow this to move around and wave around a little bit without any binding or interference. So I just need to tighten up this. This rod and this load weight really doesn't do anything except provide a handle. The weight or the rate of cut is going to be set by that damper. That damper always needs to be travelling down more slowly than this blade wants to go. That way the damper's got control of the cut and you're not overloading the blade. So where this weight goes really isn't going to make any difference, apart from general stability or balance if that damper becomes too difficult to control. Let's not make too much of a mess of that. Not as tight then, I'm never going to do it by hand anyway. So there we go. So that's it, all back together, all ready to use. So oiling this thing up is going to be a matter of poking in there. Getting that crank pin at 12 o'clock to hook into this one. So this can only pump so much pressure, but it fills up these pins with oil. Put a bit on there. Bit too much on there. There we go. All as it should be.